Welcome to this lesson where we'll explore the vital role that automated security testing plays in modern cybersecurity strategies. We'll delve into key types of security testing, the components that must be secured, and the tools used to streamline this process. By the end of this lesson, you will understand the importance of security testing, learn why security testing is critical in identifying vulnerabilities before they can lead to data breaches. Recognize the key components of security testing. Identify the main areas in software development and infrastructure where security testing must be applied, including code, artifacts/Docker images, and infrastructure configurations. Differentiate between manual and automated security testing. Understand the strengths and limitations of manual security testing versus automated tools, and how combining both methods can provide comprehensive protection. Explore DAST and SAST techniques. Gain insight into two primary automated testing methods, dynamic application security testing, DAST, and static application security testing, SAST, and their specific roles in securing live applications and source code. Finally, we will examine the benefits of automated security testing tools, understand why automated tools are widely used, including their ability to integrate with development pipelines, save time, and enhance the overall security testing process. Let's dive in. In today's rapidly evolving cyber threat landscape, businesses face constant risks of data theft and security breaches. The growing sophistication of cyber attacks, coupled with the immense financial toll and loss of customer trust that accompanies these breaches, makes it imperative for organizations to adopt proactive cybersecurity measures. One key preventive strategy is security testing, an essential practice for safeguarding sensitive information and maintaining a competitive edge. Many organizations, unfortunately, only realize the importance of security testing after a breach occurs. The urgency for businesses to take action before they fall victim to attacks cannot be overstated, and security testing provides a structured way to anticipate and neutralize potential threats. Automated security testing tools have made this process more accessible for organizations of all sizes, allowing them to identify vulnerabilities and resolve them before they can be exploited. What is security testing? Security testing refers to the systematic process of examining information systems for vulnerabilities that can be exploited by attackers or disrupt legitimate access. It serves two primary purposes. 1. Identify weaknesses, detect security flaws before attackers do. 2. Evaluate changes, ensure that updates or changes to the system don't introduce new vulnerabilities. Security testing can be conducted by the system's developers, but more commonly, independent security experts or third-party vendors are called in to perform these evaluations. In some cases, organizations are legally mandated to undergo third-party security testing to comply with regulations. Security testing often overlaps with penetration testing, a more formal and structured approach that involves actively probing for weaknesses in an application's security. Security testing is not limited to one-off assessments. It complements ongoing security efforts like vulnerability assessments and should be integrated into regular system maintenance. What are the components that require security testing? Security testing must cover all critical areas of software development and infrastructure. These include code. Testing should focus on identifying insecure coding patterns like cross-site scripting, XSS, SQL injection vulnerabilities, hard-coded tokens or secrets, and insecure third-party libraries. Artifacts/Docker images. After each build, the integrity of new artifacts or Docker images should be tested for poisoned or compromised images, insecure third-party software, and verification issues. Infrastructure. Infrastructure testing addresses configuration errors and vulnerabilities in servers, networks, and databases that host applications. By focusing on these areas, businesses can ensure their entire system, from code to deployment, remains secure. Automated versus manual security testing. Security testing falls into two main categories, manual and automated. Each has its own advantages, and often, they are used in conjunction to maximize the effectiveness of security efforts. Manual security testing. Manual security testing involves a human security expert manually evaluating an application or system for vulnerabilities. While it is slower and more labor-intensive than automated testing, it provides a nuanced evaluation of security risks. Automated security testing. Automated security testing leverages specialized tools to scan applications for vulnerabilities without manual intervention. This type of testing is quicker and more efficient, especially for large-scale applications, and is essential for spotting easily exploitable flaws in the system. Automated testing uses scripts or software to detect issues like insecure coding practices, misconfigurations, and other weaknesses. It allows for consistent testing across various applications and can be scheduled to run without requiring constant oversight. Both types of testing have their place in a comprehensive cybersecurity strategy. Automated testing offers speed and scalability. Let's deep dive into automated security testing tools. Within the realm of automated security testing, there are two primary methods: dynamic application security testing, DAST, and static application security testing, SAST. Let's explore these approaches. 1. Dynamic application security testing, DAST. DAST is used to test the security of applications in real time as they run. It simulates how an attacker might interact with the application, examining the application as it would function in a production environment. DAST can uncover vulnerabilities that only appear during runtime, such as authentication errors and server misconfigurations. By testing applications in their live state, DAST helps identify issues that might not be visible during the development phase, making it an essential tool for securing applications before they go live. 2. Static application security testing, SAST. SAST takes a different approach by analyzing the application's source code without executing it. This allows developers to catch issues like SQL injections and cross-site scripting during the coding phase. SAST is a proactive method, helping teams identify and fix vulnerabilities early in the development process before they become deeply embedded in the system. SAST is particularly useful for examining an application's code for known security patterns and vulnerabilities without needing to deploy the application. Why automated security testing tools are widely used. Automated security testing tools have gained widespread adoption due to their ability to streamline the security testing process. Here are some key reasons for their popularity. Easy integration. These tools integrate seamlessly into existing DevOps workflows, enabling continuous testing without interrupting the development pipeline. Time savings. Automated tools can scan multiple applications simultaneously, allowing organizations to secure their entire portfolio efficiently. Improved usability and efficiency. Automated tools can be applied to applications built in various programming languages, providing a universal solution to security testing. The rise of automated testing has transformed how businesses handle security, making it possible to conduct thorough, efficient, and continuous assessments without the time and resource constraints of manual testing. Now let's summarize what we have learned. Proactive cybersecurity. Security testing helps prevent costly data breaches by identifying vulnerabilities early. Comprehensive testing. Cover key areas like code, Docker images, and infrastructure. Manual versus automated testing. Both approaches are valuable, with manual testing providing depth and automated testing offering speed and scalability. DAST and SAST, two essential automated testing approaches. DAST tests live applications, while SAST analyzes source code. Widespread use. Automated tools are popular due to easy integration, time savings, and broad applicability. Continuous security. Security testing should be an ongoing practice, not a one-time event. Incorporating automated into regular business operations is a critical step in safeguarding company assets and maintaining trust with customers. To help you reinforce what you've learned and explore more advanced lessons, please click the link in the description to access this lesson on Motiva Logic Academy Learning Management System, where you'll find a quiz for every lesson, hands-on lab and projects to test and strengthen your understanding. While you're there, explore the full catalog of advanced hands-on courses and downloadable resources designed to help you move from theory to real-world expertise faster. Be sure to like, subscribe, share and visit the link in the description. Don't forget to turn on notifications so you don't miss the future lessons. Thanks for watching.